Hello guys and welcome. I hope that you're doing well. My name is UHD King, or I play 4K, aka I play 8K, aka I play 16K, and during this video I'm going to demonstrate Metra 2033 PC game running in 16K video resolution, 16K benchmark, 16K UHD, 16K gameplay. I'm going to show it to you as an extra bonus, and this is going to be the world's first 16K video resolution gameplay and 16K video resolution benchmark in Metra 2033 PC game, available as a video for you to watch, data and study it as real deal, available on YouTube. With the help of single Titan RTX video card equipped with 24GB of video RAM and Intel Core i9 9900K overclocked at 5.3 GHz. Let me use the zoom tool. I'm going to use the Windows magnifier tool by Microsoft. In the end of this video, we're gonna go through my specifications of my PC system, but before we're going to jump into the benchmark, first I'm going to show you Metra 2033 PC game benchmark, and then I'm going to show you the gameplay as a bonus. As you can see, under the magnifier tool, I'm using the 1600%, which is the maximum zoom in. My desktop is set to 16K video resolution as well. This is very crucial. 15,360 pixels by 8,640 pixels at the 100% scale, just in case. Scale used for the fonts most likely, and in 1 or 3% of the games that I tested. So just to make sure, set to 100% and 16K video resolution as your desktop, and run the benchmark in the windowed mode. Okay, let me zoom out. I'm going to zoom out. Let me close that. I achieved the 16K video resolution natively on the 8K resolution native screen, plus the NVIDIA DSR through the modified NVIDIA drivers and modified NVIDIA shadow play that is recording today. This video, keep that in mind, in real time in 8K video resolution, so please watch this video in 8K video resolution. I pre-benchmarked already the tests in Metra 2033 without NVIDIA Shadow Play recording, and right now we're gonna do it again within the NVIDIA Shadow Play recording, and then we're going to compare the data without NVIDIA Shadow Play recording, the same benchmarks, and within the Shadow Play recording, just to make sure and see what was the difference. This is an extra bonus for you as well, so don't forget to smash that like button. So presets, this is how we're gonna do it, guys. I just woke up. Today is November 24th. As you can see, it's morning and 9:30 a.m. November 24th, 2022. This type of technology was available to us all the way back in 2018. Titan RTX video card Turing GPU architecture was available back in 2018. Keep that in mind, but nobody recorded and nobody did it. Copycats doesn't know how to do it, guys. It requires a lot of intelligence to run 16K video resolution natively on 8K resolution native screen, okay, and to make sure it's real and it's forced through the brutal force through the RAM debugger tool as a software developer. So as you can see, a lot of information and experience will be shared with you as a 3D artist, graphics designer, software developer, game developer, a gamer, PC hardware enthusiast, PC overclocker throughout this video. So go ahead and stick around. It's going to be about an hour. Grab yourself a favorite drink. The favorite drink will be a water with a lemon, or a tea with a lemon, or a coffee. Keep in mind that I'm recording with artificial intelligence CPU, removing the noise because I'm sitting by the computer, and 100% fan rotation of 2 fans on the NVIDIA stock air cooler. It's kind of noisy, and it can squeak my voice a little bit because it's using the CPU artificial noise removal. I'm not using the NVIDIA RTX voice noise removal, which is excellent tool, but it's utilizing a little bit of GPU CUDA cores, shader cores, so I'm not using it. Okay, so this is how we're gonna do it, guys. 16K video resolution. I decided to go DirectX 9 and DirectX 11 just because this is the world's first 16K video resolution in Metra 2033. Why not? So I'm going to use even this 16K resolution for DirectX 9 under the low preset, 2 different presets, anisotropic filtering 4x and 16x, just for those who's curious how Turing GPU architecture doing the anisotropic filtering in terms of the texture filtering. Let me switch to 4x. No, first test 4x, second test 16x. Here we go. And then medium, then high preset, then very high preset, then we're gonna switch to enable advanced physics. Even for Turing GPU architecture, it doesn't matter. The chip of advanced physics is featured on the video card of Turing GPU architectures, such as 2000 series video cards. But anyways, it's not required additional video card for you to use like Fermi or Kepler GPU architecture required. Keep that in mind. It's featured since Maxwell GPU architecture, if I'm not mistaken, but Pascal GPU architecture didn't require additional video card for advanced physics acceleration like it was in Kepler and Fermi GPU architecture, previous GPU architecture by NVIDIA. Then we're gonna do DirectX 11 low preset 4x 16x, then medium 16x, high, very high. Then enable physics, and then I'm going to do enable depth of field. I did it without NVIDIA Shadowplay recording. It did it nice, but while I'm using the NVIDIA Shadowplay recording in real time on the same computer, keep in mind that I'm coming in real time. This is the best way of comments because I'm going to share the experience the way it is, the way I'm feeling it at the moment. So when I'm using the NVIDIA Shadowplay and enable the depth of field, it's pretty much crashing or slow FPS. Keep that in mind. So NVIDIA Shadowplay is still stressing the components, not in some games, but in this game under depth of field it does it. Look like it's sharing some components that using under the NVIDIA Shadowplay. Maybe this is what I'm assuming as software developer. So we're gonna run all these tests, guys. Okay. So let's go ahead and do it. I'm going to go ahead and overclock my Titan RTX video card. As again, in the end of this video, we're going to go through my specs, but keep your eye at the pixel fill rate, textual fill rate, and especially video RAM bandwidth is going to increase a lot when I'm going to overclock for free my Titan RTX through the MSI Afterburner. The video tutorial how to overclock RTX 2080 Ti video card or Titan RTX video card as best as possible will be available over the UHDking.com. Go ahead and check it out. My guide will be the best. So I just overclock it, and you can see it's improved pixel fill rate by 10 gigapixels per second, textual fill rate improved by 30 gigapixels per second, and bandwidth improved by 120 gigabytes per second. So right now I'm faster than RTX 3080 video card bandwidth in terms of the VRAM. And Titan RTX is a hair slower than RTX 3080 video card, but Titan RTX featuring double, even more than double of video RAM. That's why it's possible to run the Metro 2033 PC game under 16K video resolution on a single Titan RTX because we have enough of video RAM. RTX 3080 video card can handle in terms of GPU computing performance, but it cannot run the game in 16K video resolution because there's going to be lack of the video RAM due to 10 gigabyte of video RAM. Even the RTX 3080 Ti, which is faster than Titan RTX, but it's not going to have enough video RAM to run it. So only RTX 3090 video card or RTX 3090 Ti video card with 24 gigabyte of video RAM, or of course RTX 4090 video card or better can run this game that is equipped with 24 gigabyte of video RAM is required at least, guys. But better video RAM you have, the better, right? So this is how we're gonna do it, guys, and let me go ahead and do it. I'm going to zoom out. So I'm going to use a lot of zoom tool, Windows magnifier tool by Microsoft, and also the audio track is on rest. Elephant is all right reserved, no royalties can be claimed, provided by the YouTube. So let's go ahead and do it, guys. Under the user CFG file, you want to make sure open up for the Method 2033 and change the full screen from on to off. It's going to be a full screen command here. It's changing from time to time, especially when you're running benchmark. Make sure to switch it because it has the flickering shadows when it's running 16K video resolution on Turing GPU architecture in full screen. So I'm going to bench it under the windowed mode. Keep that in mind. So our full screen off. Make sure this command in the user CFG file for the Method 2033 under the your computer name, app data, local 4A games, Method 2033 is set to off and save it. Okay, this is how I'm gonna do it, and let's go ahead and do it, guys. So without any modes, the classic vanilla Method 2033 by 4A games, running 4A games game engine. Okay, I'm going to go ahead and execute it, so everything is ready to go. Let's go ahead and do it, guys. Let's cross the fingers. By the way, on the background, this is my system. Single Titan RTX is only installed. I have two Titan RTXs in SLI, and Method 2033 supports SLI. So we're going to test two Titan RTXs in SLI because SLI is supported on the DirectX 9, DirectX 10, and DirectX 11 API, but doesn't support it on DirectX 12 API. So keep that in mind. So we're going to test it. Do that game is supporting SLI as well. So stick around for that, and more videos will be available over the UHDking.com with 2 Titan RTXs in SLI under 16K video resolution, and it's going to be nice to see because it's going to be faster than RTX 3090 Ti video card. Keep that in mind when 2 Titan RTXs in SLI. But it's going to be slower than RTX 4090 video card. As you can see, the FPS is 19, 20, 21 FPS average, latency delay below 10 milliseconds, I mean below 100 milliseconds, but above 40 milliseconds, so it's not playable. But the reason of this benchmark is not to play, it's just to benchmark it in real time, hopefully. And this is the first vertex or the first coordinate towards the 16K video resolution benchmark in Metro 2033 PC game that we're going to use in the future, because it's using a great game engine and it's utilizing all the way to 16K video resolution as maximum rendable resolution in real time in PC games under DirectX 9 API, DirectX 10 API, DirectX 11 API, DirectX 12 API, Vulkan 1 version all the way to 2.0 APIs, OpenGL all the way to 5 version API. 16K video resolution is the maximum supported rendable resolution in real time for the 3D world or 3D scene. I'm going to prove it to you guys in the end of this video. Please stick around, keep that in mind, as again in the end of this video we're going to talk a lot about my PC configuration as well. Alright, so low preset 4x, we're running the second set, and now it's about to switch to third set. As you can see, I'm going to run 3 sets just in case we're gonna get the proper data value of the averages. And yeah, great performance, especially when I'm going to try 2 Titan RTXs video cards. Look like it's going to be playable in real time, playable status for the classic gamers that can play in 30 FPS average. Because they look like the FPS right now is almost 20 FPS average while recording with NVIDIA Shadowplay in 8K video resolution in real time. Without the 8K video resolution codec that was introduced for the RTX 4000 video cards, but as again NVIDIA GeForce Experience and NVIDIA drivers was modified by me, those drivers, and keep that in mind, and game experience software. So it's recording in 8K video resolution. Please watch this video in 8K video resolution, just switching your YouTube player to 4320p or 8K UHD. Okay, not bad, 20 FPS even sometimes, but pretty much staying like average 16, 17 FPS. That means that 2 Titan RTXs will show at least 30 FPS if both GPUs will be scaled to 100%. It's not going to be 2x because the first GPU, the first video card that's going to be closest to the CPU will be overheating, while the second one will be cold, like 50 Celsius, and it's going to thermal throttle the frequencies a little bit. So it's not going to be 2x due to that scenario. It's going to be like 1.85, 1.8x, but it's still going to be a great boost, guys, and it's going to be a playable FPS, I think. But we're going to find out. I cannot wait to test it myself. Keep in mind that I already pre-tested in Metro 2033 Redux PC game as well. It's supporting 16K video resolution as well. It's running updated game engine, but it's a little bit heavier game engine, and I'm going to demonstrate it for you as well as a benchmark and gameplay videos over the UHDking.com. So don't forget to smash that like button, support me, guys, positive comments, a lot of time, money, energy, share it with your friends. Great FPS. This is 16x, but it's going to be not such a difference between 4x and 16x, but I did it just in case as a proof for those who's curious for an extra data. Wow, that's impressive, guys. This is unbelievable. The almost 18,000 megabytes of our video RAM utilization, as you can see at the left top corner, but we still have to go like almost 8 gigabytes of VRAM if needed. And this is started with the low preset, and it's doing it in real time. It's almost playable status also on a single Titan RTX video card. As you can see, GPU utilization is constantly at 99-100%. When we're going to switch to a higher preset, such as high or very high preset, my GPU utilization will jump to 100%. So GPU utilization is healthy. We want to keep our GPU utilization 97% and above. 99-100% is an excellent GPU utilization, amazing GPU utilization. CPU utilization, we want to keep all the time below 90% of this overall CPU utilization, but as you're gonna see, it will never reach even 50% of the CPU utilization. And right now I'm running i9-9900K, only 6 cores, 6 physical cores, 6 physical threads. So I disabled 2 physical cores cores and hyper-threading technology, which is additional 8 logical cores in the BIOS, because for the 9000 series Intel CPUs, 3 logical cores are equal 1 physical core or 1 physical thread. Keep that in mind. So it's pretty slow. So I disable all the slow logical cores, and I'm running only physical cores, physical threads at the 5.3 gigahertz to keep it stable, rock solid stable, and to cool it down, because i9-9900K above 5 gigahertz with 8 physical cores and 16 logical threads is not coolable even with the Corsair H150i Pro 360mm radiator AO and 3 120mm fans. I cannot cool it, guys. It's thermal throttling 100 Celsius all the time, above 5 gigahertz on 8 physical cores, 16 logical threads. So to boost up additional 300 megahertz stable and safe, what I did, I disabled 2 physical cores in the BIOS and disabled the hyper-threading technology, which is additional 8 logical cores. Beautiful FPS, guys. This is the medium preset right now, 16x medium preset, untouched medium preset. The VRAM utilization is almost 18 gigabytes, as you can see, but almost the same as low preset. The system RAM utilization, you also want to keep your eye at the system RAM utilization, because when we're going to start offloading some data from the video RAM to the system RAM based on NVIDIA drivers, NVIDIA IDEA, how the pipeline for the GPU, it's going to use after the video RAM when it's overloaded without crashing the game, is offloading some data into the system RAM if it's possible without crashing the game, and that process is very slow. It's increasing the MS. That MS stands for the milliseconds. The lower value is better by that FPS. So milliseconds, increase the milliseconds latency delay between the hardware and software, hardware such as GPU, video RAM, CPU, system RAM, and software such as Windows 10 professional operating system, in our case DirectX 9 and 11 API and NVIDIA driver. It's all generating the latency delay, and latency right now is above 50 milliseconds. As you can see, the playable comfortable latency delay will be below 20 milliseconds, excellent latency delay will be below 10 milliseconds, and kind of semi-playable latency delay will be around 30 milliseconds. Above 40 milliseconds, this is where the gameplay is not playable status, is kind of uncomfortable. Keep that in mind. And above 100 milliseconds latency delay is a clear sign that we are already offloading some data from a video RAM into the system RAM, or GPU performance is not enough to compute frames in real time. Okay, and usually it's going to show like 3-4 FPS when your latency delay above 100 milliseconds. It's a clear sign that it's offloading some data from the video RAM into the system RAM if you have at least above 3 FPS. If you have 0-1 FPS, that means you don't have enough GPU performance through your shader cores, in our case through the CUDA cores, to compute in real time, or another reason will be not enough video RAM, and it cannot offload a lot of data into the system RAM without game to go extra slow and be able to render in real time, and in some cases it's even going to crash. Anyways, the Tor test and the medium preset recording with NVIDIA Shadow Play, but it doesn't matter for Metro 2033 because FPS will be so low. So with the NVIDIA Shadow Play recording or without NVIDIA Shadow Play recording, we're not even going to lose 2 FPS. Keep that in mind. Usually it takes like 3 FPS for Turing GPU architecture while using the NVIDIA Shadow Play recording. Please keep that in mind. 3%. Usually it's using 3% out of your overall FPS. Okay. As again, in the end of this video, we're going to study the data, the value of the data, which will be pre-benched without the NVIDIA Shadow Play recording and within the NVIDIA Shadow Play recording. As you can see right now, the maps are popping up, so it's building the textures out of the maps. You can see the normal map, ambient map, and etc. And it's building the textures and diffuse maps, and it takes some time. I believe the GPU is computing in real time, pre-caching the important data that can be pre-cached, and this process takes some time, and after it's going to be done pre-caching, we're going to have a final textures, and then everything will be running in real time and much faster. So this process takes some time, and I believe it's due that benchmarks is supposed to wait a little bit longer while all the textures going to be pre-cached, but this game engine is precaching some textures through the way the camera is flying on a level through some sort of radius, and after it's going to precache those textures into the final textures, those maps into the final textures, it's going to speed up nice, and textures will be what it's supposed to be, like right now, as you can see. But that process takes some time, and that process can be due to the level second cache, because level second cache is the second fastest cache through the NVIDIA GPU pipeline after the first level cache, and video RAM is way slower than level second cache. Just for those people who's curious, level second cache in Turing GPU architecture will be like 1.7 gigabytes per 1.7 terabytes per second data bandwidth, while video RAM 679 gigabytes per second on the Titan RTX video card, while the second level cache 1.7 terabytes, not gigabytes but terabytes per second. Okay, on the RTX 3090 Ti GPU GA102 in pure GPU architecture, the second level cache under the micro benchmarks using the CUDA, it tested as 3.2 terabytes per second level second cache on the pure GPU architecture flagship GA102, and after the test in EVGA GPU architecture such as 102, the flagship, which is at the moment only RTX 4090 video card, but this is not the flagship of the EVGA GPU architecture, the raw GPU architecture, please keep that in mind. And the ED102 RTX 4090 video card is not the flagship, but under the micro benchmarking tool using the CUDA, it scored I would say at some point it scored 4.9 terabytes per second. At some point it scored almost 6 terabytes per second level second cache. How fast it is versus the 1 terabyte per second on the video RAM GDR6X that featured on the RTX 4090 video card. Okay, so you can imagine now, based on figures, how fast the second level cache, which is slower cache, a slower memory when it comes to first level cache, but first level cache just a little of amount that can be pre-cached. Second level is larger than first level cache, and video RAM is huge. Second level on RTX 4090 video card is 72 megabytes. Total can be utilized by all the stream multiprocessors SM units or SM blocks that storing CUDA cores in them. So they're using level 1 cache that's going to be dedicated to stream multiprocessing units with a limited amount of the CUDA cores on them, and the second level cache can be shared between all of those stream multiprocessing units on all of those CUDA cores, keep that in mind, while video RAM can be shared entirely on a whole GPU. After, it's going to utilize the level 1, then level 2, and then it comes to video RAM, and then it comes to system RAM. Okay, I studied this information, guys, while I played with the CUDA under the C language based on NVIDIA manuals. You're going to learn a lot about the GPU architecture pipelines, how the L1, which is level 1 cache used on the NVIDIA GPUs, level 2 cache used, and AMD video cards is also using the level 3rd cache, but NVIDIA stick to two-way caching, which is level 1 and level 2 before it's going to use a global memory such as video RAM. Keep that in mind. Anyways, beautiful performance, by the way, and I believe this is going to be a high preset, if not very high. I think, yeah, this is a high preset. This is not very high, but this is the high preset on the DirectX 9 API yet. Beautiful performance, CPU utilization not even 40%. I even didn't see under the low preset 40%. The higher preset will be, the lower CPU usage will be. So as you can see, guys, the future will not be about CPU cores featured on your CPU. This is a false information. That's why Nexus Gamer and Linus testing the games under 1080p and 1440p, because those company pays them money. But CPUs are done for PC gaming. You want to have a nice video card, and you don't want to have that CPU with the 24 cores and such as like that. You don't want to waste that money. You want to have around 6-8 cores if you're playing above 4K resolution and clock as high as possible on those CPUs as external frequency. This is the only advantage when you're gonna gain advantage in form of the FPS. Hopefully guys this makes sense. The higher resolution, the less CPU cores, the less CPU threads you need to use, but the higher frequency will always give you an advantage in terms of the CPU performance, okay, no matter what the case. Is it 3D rendering or PC gaming or some other workstation tasks? Let me double check. 1 second guys, let me see where's my mouse cursor. Everything is such a small. I'm looking for my mouse cursor. I'm trying to locate right here. Try to zoom in using the zoom tool just to zoom in over here and see. Okay, so we tested very high preset on the DirectX 9. So right now we're doing the DirectX 11 low preset, I believe, or we're doing the high preset with the, yeah, right, this is the next one, very high preset but with the physics on. Advanced physics is on. So let's go ahead and have a look. Oops, guys, I forgot. I don't want to test, I don't want to the, 1 second guys, where's my mouse cursor? Let me bring right here. I don't want to ruin my benchmark by pressing escape while using the magnifier tool. Hopefully guys this makes sense. So I open up the window and zoom out. But the Windows magnifier tool, the zoom tool, will be very handy when you're talking above 8K video resolution for sure, or even 8K video resolution. It's very handy as a workstation throughout your work processes, work tests, throughout different applications. The magnifier zoom tool by Microsoft is amazing software. And I'm, as a pioneer, guys, introduce it to you. By the way, I'm sipping a nice Swiss hot chocolate mixed with the coffee. It's amazing, guys. So just woke up and decided to share with you the world's first 16K video resolution, 16K video gameplay. You're not gonna see it anywhere because those copycats doesn't know how I'm achieving that, how I'm achieving native 16K video resolution. It's required, as again, a lot of intelligence. It's not just a copycats. So they're copying each other on YouTube, and over here you're watching the unique content. So don't forget to smash that like button, subscribe, share it, positive comments, and feature me on all your friends' websites and forums and such like that. I will appreciate that. The data is correct, guys. I am responsible for everything what you're watching at the left top corner, and it's self-explanatory, as you can see. So when our system RAM utilization will go above 12,000 megabytes, that's mean a clear sign that we are offloading some data from a video RAM into the system RAM. As you can see, Metro 2033 under 16K video resolution requires below 12 gigabyte of system RAM, but 12 gigabyte will be enough. But when that value will be increased about 12,000 megabytes or 12 gigabytes, that means a clear sign that we are uploading some data from a video RAM into the system RAM, okay? And system RAM, of course, is increasing after I'm switching the presets through the benchmark, as you can see. Still rendering in real time. This is the latest preset, latest benchmark under the very high preset with advanced physics on, DirectX 11 API. And we're about to switch to DirectX 11 API, and the difference in Metro 2033 PC game between the DirectX 9 API and DirectX 11 API will be pretty much the tessellation. They use the tessellation feature that is available as a classes to use for any developer pre-built classes on the DirectX 11 API by Microsoft. That's the only difference. So the visuals will be the same, only when you're going to look on the characters, 3D models, they're going to be more detailed because it is going to feature more polygons. So tessellation process or feature is pretty much splitting the polygon into the 2, 3, 4, 5, 6, 8, 9, whatever polygons, and it's forming better shape. Hopefully guys this makes sense, because more polygons, more those squares, triangles, forming better shapes, and then when you're putting the texture it's looking better, more native to it than just a square. So let's say through the tessellation process 16, you can make from a square, you can make a sphere, okay, because the those polygons will be splitted and going to create a sphere. Hopefully I made a clear sense for you. So if you were trying to make kind of spheric object from a square, you're going to use the tessellation, or you're going to just put the better model. But to be able to use the tessellation feature, you can use the same game on multiple hardware. So but by just switching the presets, low without the tessellation and high within the tessellation, or let's say low under DirectX 9 API and high under DirectX 11 API, or wherever the game developers will envision. In our case, you're switching completely entire just API under all kind of different presets, and API in our case will be featuring the tessellation. But tessellation pretty much will bring more polygons to the scene. This is the role of it, while modifying the 3D geometry into more polygons and splitting those polygons into more polygons. Hopefully guys this makes sense, and this process will create more polygons to compute for the GPUs, and it will struggle a little bit, but it no matter for Metro 2033 PC game and Turing GPU architecture is going to chew it like it's nothing for Turing GPU architecture since Maxwell GPU architecture. But there was a problem on the Kepler GPU architecture, and since Maxwell GPU architecture is already not a problem. Especially Pascal GPU architecture, tessellation is not that big problem. It's only like 10% of the performance lost when tessellation is on. While on the video cards before the Maxwell GPU architecture, such as Kepler GPU architecture, it was way above just the 10%. It was like almost solid 50% of the GPU performance loss in terms of the FPS when tessellation was enabled. Hopefully guys this makes sense. As you can see, Titan RTX video card outputting instead of 7000 MHz on GDR6, which is external frequency, will be 14,000 MHz output frequency on GDR6. It's doing 16,600 MHz, which is 2,600 MHz more, or 1,300 MHz to be exact more, but you gotta multiply it by 2 because it's GDR6 for the output external frequency. And it's fast guys. It's 120 gigabytes per second additional boost. I receive additional boost for free through the video card overclock more than I'm receiving my system RAM bandwidth, because right now out of my, this is the fastest scenario of DDR4 by the way. Yes, it is 3200 megahertz, but it's not CL16, not even CL14, it's CL11. The lower value is better, so it's creating a latency below 45 nanoseconds. Latency delay, system RAM, memory delay between the CPU and system RAM, it's below 45 nanoseconds. This is unheard of under the IDA64 benchmark. In the end of this video I'm going to demonstrate it for you. So but it's still 50 gigabytes per second bandwidth. 50 gigabytes, not gigabits, but gigabytes per second bandwidth out of this DDR4, which is great. It's running dual channel, great for DDR4 and dual channel, supported by the 9000 series CPU. This is kind of everything, we're squeezing everything what we can from this CPU right now, from the 9000 series, running 3200 megahertz DDR4 at CL11 with below 45 nanoseconds latency delay, but the bandwidth is 50 gigabytes per second, and it's not even half of the bandwidth that we delivered just through the free overclock on our GPU. Keep that in mind, on our video RAM. So our video RAM delivering just from the video RAM overclock twice more bandwidth than our system RAM is capable to push. That's why when it's offloading some data from a video RAM into the system RAM, everything is slowed down. Hopefully guys this makes sense. As you can see, I'm explaining a lot of details for those newcomers because a lot of new people watching it, and I'm trying to explain for any kind of field of view, any kind of personality out there, as hopefully you're receiving a lot of value, because my videos will feature multi-angle value guys in them. No matter who you are, PC gamer, PC hardware enthusiast, PC overclocker, game developer, software developer, 3D artist even, or graphics designer, you're going to learn a lot by just watching my videos guys, especially when we're talking ultra HD resolution, such as above 8K video resolution. And I was the first YouTuber that introduced 16K UHD for you, 16K video resolution or 16K gameplay back in 2015 in Counter-Strike game, before the Counter-Strike Go, and it was over different YouTube channel, and over this YouTube channel, which is UHDking.com, I introduced 16K video resolution back in 2016 on 4 Titan X Maxwell GPU architecture. But my first 16K video resolution render in a PC game was back in 2015 on 4 Radeon R9 290s in Crossfire. Keep that in mind. On my first quad Radeons. No, it was my second quad Radeons. I believe my first quad Radeons was 7970s. when I started my Bitcoin mining. By the way, Bitcoin mining in 2022 is went down due to the complexity increase, and complexity is going to increase in the next 8 months, so it's not going to be even profitable to mine on Turing GPU architecture. In 2020, mining on Turing GPU architecture Bitcoin per day was $8. $8 if you're gonna overclock the Titan RTX properly per video card. Okay, in 2020. In 2022, mine the same using the same algorithms, mine the Bitcoin is only 35 cents because the complexity grows, guys, of the Bitcoin, and every year it's harder and harder to mine the Bitcoin. You need to have faster and faster GPU computing performance power if you're looking to mine it on video cards and gaming video cards. But even on the RTX 4090 video card, mine the Bitcoin in 2022, I tested in November on one of my buddy computer, it's only 59 cents per day. So double over the Titan RTX, a little bit less than double. So NVIDIA also artificially locked the mining capabilities of the EVGA GPU architecture. Keep that in mind. While on the Ampere GPU architecture, such as RTX 3090 video card, the mining performance was double over a single Titan RTX video card. So when I was mining $8 on the Titan RTX in 2020, in the 2021 when I did the test on the RTX 3090 video card, it was mining $12, almost double in terms of the value. But then NVIDIA locked it in 2022 on the RTX 4090 video card in EVGA GPU architecture by NVIDIA, and now that video card is delivering the same performance as RTX 3090 video card in terms of the mining, but it doesn't make sense because it's double faster than RTX 3090 video card when we are talking RTX 4090 video card. Hopefully guys this makes sense. Anyways, great FPS, DirectX 11 API at low preset, 20 FPS average, but sticking like 17-18 FPS average, which is great when we're talking 2 Titan RTXs and SLI, as again this game supports 2 Titan RTXs and SLI under DirectX 9 API or under DirectX 11 API, and I'm going to demonstrate it for you. Cannot wait to do that. I didn't try it myself yet. Hopefully it's going to run without any issues. Cannot wait to see the performance. Is it going to be playable? 16K video resolution in Meta 2033, the game from 2010, which is absolutely amazing, by the way. This game, guys, was introduced to us in 2010, and this is, as again, Meta 2033 classic version without any mods, and there is a Redux version of Meta 2033 that's using updated version, a little bit heavier, and it's going to show a little bit less FPS. But over the UHDking.com, we're also going to test Meta 2033 Redux version under 16K video resolution, Meta Last Light under 16K video resolution, Meta Last Light Redux version under 16K video resolution, and Meta Exodus under 16K video resolution. I was the first YouTuber that showed you Meta Exodus PC game under 16K video resolution, 16K UHD back in 2020, guys, on 2 Titan RTXs and SLI, and on single Titan RTX video card and SLI. And without SLI, go ahead and check out the video comments below this video description, or in the end of this video I'm going to post those videos for you to check out. You don't want to miss it. As again, I was the first YouTuber, UHD King, aka I play 4K, aka I play 8K, aka I play 16K, was the first YouTuber that did Meta Exodus back in 2020 in 16K video resolution, natively rendered, guys. As again, it's rendering natively, guys. This is exactly how much it's gonna take to render before outputting your signal. It doesn't matter how many hertz your monitor, how big your monitor, any 16K video resolution monitor, this is exactly how much performance it will deliver on a Titan RTX video card. And then I'm outputting the signal to my 8K resolution TV, which is scaling down the signal, but it doesn't matter, guys, and it's scaling down through the NVIDIA DSR tool from 16K to 8K resolution, but it takes like 1 FPS throughout the process to downscale. The downscale is great, guys. Through the downscale process you make everything more detailed, but through the upscale is horrible. You don't want to upscale. Even upscale through the AI can eliminate the issues, a lot of issues that comes through the upscale, like pixel distortion and such, noise, but still upscale is not as good as downscale. When you rendering in native and then downscale, you're going to receive a beautiful image if you're going to render, let's say, 4K resolution and upscale to 8K resolution versus the 16K resolution natively render and downscale to 8K resolution, you're gonna see the difference even like that. Okay, but 8K resolution native render this game versus 16K resolution native and downscale to 8K resolution native, guys, I can see the difference, believe me. Okay, and you will be able to see the difference, especially when we're talking screens above 65 inches. Above 70 inches for sure, you're going to see the difference when you're going to run DSR 16K resolution native and then downscale to 8K resolution. You're going to see the difference versus the running just 8K resolution native. Believe me, guys. Okay, I can see the difference, and of course you got to have a great vision and know exactly what you're looking at. But under the zoom, you can see the difference, guys. Okay, hopefully I will demonstrate it for you when it's going to run very high. I'm going to demonstrate the difference under 16K video resolution with 1600% zoom, and you're going to see the difference. The pixels even under 16% zoom will be so sharp, so detailed. It's going to be unbelievable. All right, so I believe this is high preset. It's not even medium preset. It's the FPS is 10 FPS. As you can see, for Turing GPU architecture, when you switch in between the APIs, DirectX 9 API or DirectX 11 API, it doesn't matter actually for Turing GPU architecture. And even since Pascal GPU architecture, Maxwell a little bit matter, but Pascal GPU architecture also didn't matter. The GPU architecture has so many CUDA courses Turing that in 16K, even 16K video resolution, like it's no problem. Let me show it to you. So I was running, let me see, I was running, yes, high preset, advanced physics disabled, tessellation enabled. Tessellation will be enabled after medium preset under DirectX 11 API for the Metro 2033 PC game, keep that in mind. Anti-aliasing off. Anti-aliasing is crashing, guys, even without the recording, keep that in mind. Anyways, let me go ahead and show you the zoom tool and show you exactly this 1600% zoom tool. So you're gonna see what's up over here. So right now it's pre-caching. It's not pre-cached yet. Still pre-caching at very high. It's running very high preset. So first benchmark will be pre-caching. The second one, let me demonstrate you 1000% and 16K video resolution zoom. So let's go ahead and have a look, guys. So it's still pre-caching, as you can see. Maps are still baking. It's not ready yet, but this is 1000% and 16K video resolution native. Just zoom into it. You saw how ugly was that NVIDIA logo, which was like very low resolution, static resolution. But 3D is not static resolution. 3D is scalable resolution, guys. Keep that in mind. At different angles, the texture and the amount of pixels can show different amount of details. And 16K video resolution is underlining to make sure that you're rendering every single pixel. Check it out. This is unbelievable, guys. This is the size of the screen right now. At 1600% under 16K video resolution will be exactly the full amount of the 4K resolution. So 1600% actually, like right now, zoom, this is the size of the 4K resolution screen, because 16K video resolution will be 16 times 4K resolution screens. So 16 4K resolution screens can create an array of 16K video resolution screen, or 4 8K resolution screen can create an array of 16K video resolution, which is 132.7 megapixels. And this is exactly, if you're going to zoom in, imagine if you're going to zoom into the pixels on 4K resolution under 16K resolution zoom tool, magnifier zoom tool to the maximum ability of the magnifier, Windows magnifier zoom tool, 1600%. Under 4K resolution, everything will be so pixelated, but over here you can see the details, and they're so detailed. That means this is the little area, 1/16 of the screen, and this is the level of details, 1/16, the little spot of the screen. So if you are having 85 inches, it's going to be so sharp and so detailed. It's even going to be more detailed, as you can see right now, because I zoom into it. So hopefully, guys, this makes sense. Hopefully I explained it to you pretty well. Let me zoom out real quick and get back to the benchmark. Here we go. So the third test, okay, this is the third test. We'll do it right. We did one test, so we're going to collect the data anyways from one test, correct data. From the second test, while I was testing on the third test, because the first test on the very high is pre-caching, as you can see. That's why I did the 3 tests. So you're gonna witness that. So it's building from the maps, the final textures, is baking it. The pre-baking process, probably through the game engine. This is how I call it as a game developer, software developer. And it takes, as you can see, the full cycle of the full benchmark under the first test. This is how heavy it is, and Turing GPU architecture, even using 6 megabyte of level second cache and 4306 CUDA cores, not fast enough to pre-bake it in real time. So I cannot wait to test it on RTX 4090 video card EVGA GPU architecture with 72 megabytes of level second cache. But guys, please keep in mind that the AD102 GPU, which is the full EVGA GPU architecture by NVIDIA, the flagship, without any cards, the full GPU architecture is featuring 96 megabytes of level second cache, and the RTX 4090 video card is featuring 72 megabytes of level second cache. That means that we have 20 megabytes to go. 20 megabytes, 96 megabytes, 72 megabytes, not gigabytes, sorry. So 20 megabytes to go on level second cache. That means that it's going to be RTX 4090 Ti video card for sure, or Titan, some new Titan. Hopefully NVIDIA gonna call it Titan King or RTX 4090 Ti, but it's going to feature 48 gigabytes finally on a gaming video card, because for the enterprise solutions on the video cards, since Quadra RTX 8000 video cards that was part with the Turing GPU architecture with the same GPU as I'm running right now, but it was featuring 48 gigabytes of the GDDR6 register memory, while Titan RTX running 24 gigabyte GDDR6 on register memory. So pretty much Quadra RTX 6000 video card will be equal as Titan RTX video card. Same thing, but only the difference will be video RAM, which will be registered on RTX 6000 video card, Quadra, and Titan RTX is going to have unregistered GDDR6 by Samsung. That's the only difference. If you're going to flash the BIOS, the video card is not going to start, so do not flash the BIOS on the Quadra RTX 6000 video card, even if everything is identical, because the difference will be in your memory chip. Go ahead and have a look at your Samsung GDDR6 memory chip, compare them on Titan RTX and on your Quadra RTX 6000 video card, and you will see. And of course, RTX 8000 video card, the same GPU but more video RAM, which will be TU102 GPU by NVIDIA, same GPU that featuring the same amount of CUDA cores, the same level second cache, everything the same, but it's going to feature 48 gigabyte of GDDR6, and hopefully it was featured like that on the Quadras Ampere and Quadras Ada. Hopefully NVIDIA going to introduce on a gamer video card such as EVGA GPU architecture 48 gigabyte video card such as RTX 4090 video card as 4090 Ti or Titan King, so we can utilize the EVGA GPU architecture to the fullest under 16K video resolution. Because okay, right now guys, it's running DirectX 11 API with advanced physics and depth of field, and depth of field is not going to be go good here. So it's not going to render in real time, but I want to demonstrate it for you. I think it's going to be due to the video RAM overload. Keep that in mind. It did render in real time without NVIDIA Shadow Play recording, but I believe throughout 3 benchmark tests within the depth of field, it's not going to render in real time because it's still baking at the same time the textures. I think when it's going to be done baking, it's going to render in real time, but just because it's recording with NVIDIA Shadow Play, it's stressing more on our video card, Titan RTX video card. It's not going to do it in real time, even under 3 benchmarks. So I'm going to go ahead and create the benchmark, but as you can see, it started 22,600 megabytes of our video RAM utilization, and our system RAM utilization jumped from below 12,000 megabytes to almost 16,000 megabytes. So we almost offloaded 4 gigabytes or 4,000 megabytes of the data from video RAM into the system RAM. That's why it's created a lot of latency delay and slow FPS, because system RAM is much slower in terms of the nanoseconds versus the video RAM, and in terms of the how much bandwidth it can push, how much data it can push in real time per second. versus the video RAM when it comes to system RAM. Hopefully guys this makes sense. In the end of this video I'm going to underline it for you so everything will make clear, but as you can see latency delay above 5000 milliseconds, so it's not even rendering in real time. I'm going to go ahead and stop the benchmark. I think the video RAM utilization over here around 26-28 gigabytes of video RAM utilization, but the best way for us to find out when I'm going to test it with a video card that's going to feature more than 24 gigabyte of video RAM, hopefully a video card with 36 gigabyte of video RAM or 48 gigabyte of video RAM. Most likely if it's going to be NVIDIA video card, it's going to be feature 48 gigabyte of video RAM. If it's going to be AMD video card, most likely it's going to feature like 32 gigabyte of video RAM, because they like the 16 gigabyte video RAM. Most likely they're going to do 32 gigabyte of video RAM, but I think when it comes to NVIDIA, they most likely they're going to feature 48 gigabyte video RAM just to copy the schemes of the video RAM layouts from the previous enterprise version of the video cards. I think NVIDIA will be featuring 48 gigabyte of video RAM in the next flagship. Keep that in mind. But anyways, you got an idea guys, and everything was displayed for you at the left top corner. As you can see, it's still pre-caching, but it's going to pre-cache like 3 cycles, and we're not going to see the real time. Right now it's 1 FPS, but it's probably going to be like 3 FPS when it's going to be done pre-caching. This is how it was without NVIDIA shell play recording, but just because it slowed down the system because it's recording in real time, only consumes though 3%, but still slowing down a little bit of system. In our case, when I'm using the depth of field in this particular game, it's utilizing the same components look like and slow down by a lot, especially when it's pre-compiling the level. But it's not going to be the case when it's going to be done, but you gotta wait, and it's not going to be enough time for us to wait and to compile the whole level even under 3 cycles. So I'm going to go ahead and cancel the benchmark with the escape button. As you can see, it was under 3rd run and it's still not pre-compiled the whole level. So I just stopped the benchmark. Let's go ahead and study the data now. So we're going to study the data that was collected, and then I'm going to show you the gameplay after the benchmark, but pretty much the data and everything will be almost the same. But for those naysayers and for those people who'd like to receive an additional information as a bonus, as again, you don't want to forget to smash that like button. So first benchmark was pre-bench without NVIDIA shadow play recording. So as you can see, low preset, AF4X, which is anisotropic filtering 4X for our textures, and pretty much 18 FPS average constantly, and average 18 FPS. Great result. You can see the graph at the right corner as well. The Metro 23 developers did a good job while integrated the benchmark. It's a good game developing over here. And game development, the proper way of game development, you always want to include the benchmark so people can test. So this is low preset 4X, then so 18 FPS average. So this is 16X without the recording, also 18 FPS average. So there is not such a big difference, 18-17 FPS, even a little bit lower, but not even by 1 FPS. For Turing GPU architecture, same thing will be for Pascal GPU architecture, and a little bit difference will be for Maxwell GPU architecture, maybe 2 FPS, but not that big deal, since Maxwell GPU architecture for NVIDIA. Medium preset on touch, 19 FPS, 18 FPS, 19 FPS. So medium preset is even higher FPS than than low FPS, because I think the GPU utilization completely utilize all the CUDA cores available in every stream multiprocessing blocks or units. Keep that in mind. So at 10 FPS average right here, this is going to be the high preset under DirectX 9 FPS, 9 API, sorry, and average 10 FPS, great result. 2 Titan RTX and SLI will show almost 2x performance. The very high preset, 7 FPS average. And as again, I understand this is not playable, this is benchable, but this is the first vertex, the first coordinate towards 16K video resolution benchmarking in Metro 2033 PC game that we're going to use in the future, within the future PC hardware, video card, CPU, and other type of technologies. Okay, 7 FPS average, great result for very high preset. Now it's going to be very high preset and enable tessellation under the DirectX 9, even tessellation enabled. Check it out. No, tessellation not supported. DirectX 9 doesn't support tessellation, especially in Method 2033, because they use the API for that pre-built class of DirectX 11 API. It's a physics enabled now, and still same 7 FPS. Just like I told you, Turing GPU architecture has the chip since Pascal GPU architecture ability, or even Maxwell GPU architecture, that advanced physics chip doesn't require additional video card. It's already built in on a video card. So now it's going to be DirectX 11 API, low preset, same kind of FPS, but 22 average. Wow, 21, 22 average. This is a great result. Actually, DirectX 11 API utilizing a little bit better, look like. Wow, look at this. This is 16x, 22 FPS average. So that means two Titan RTXs over here will show almost 40 FPS for sure average if it's going to scale 100% per GPU under the SLI for those two Titan RTXs video cards, and we're going to find out. So medium preset, 21 FPS, still great. Look at this, 21 FPS. Average medium preset DirectX 11 API, as again without NVIDIA shell pre-recording. Every single result that I showed you right now without NVIDIA shell pre-recording. High preset 12 FPS, higher than under the DirectX 9 API. Wow, Turing GPU architecture shows better result on the Method 23 PC game under DirectX 11 API than versus DirectX 9 API. And the game engine by the 4A games is excellent, guys. It's almost like overlay, and they didn't limit, as you can see, the game engine. They didn't limit the DirectX 9 or DirectX 11 API with the artificial limitations, so it's just like an overlay layer. That's all. Great game engine. 8 FPS for very high. Wow. So yeah, DirectX 11 API show better scale with the Turing GPU architecture on the Method 2033 PC game. Alright, so this is going to be very high, of course without the anti-aliasing, because anti-aliasing, even not rendering without the NVIDIA shell pre-recording, is crashing. So this is tessellation enable, as again tessellation enable under DirectX 11 API with the medium preset, enable physics, but depth of field disabled. 8 FPS, so it doesn't matter with physics, as you can see. And now it's going to be depth of field enabled, the last benchmark that is impossible to run while I'm recording with NVIDIA Shadowplay, because most likely, as again, it's utilizing the same components of the video card. But anyways, that NVIDIA Shadowplay utilizing, while Method 2033 PC game engine utilizing. Depth of field enable 3 FPS, caught over 50% of the FPS with that depth of field. That depth of field is not a great idea, and it's going to create that blurriness at some point. You know what is depth of field? At some radius, at some distance, it's gonna blur, and blur details depends what point you're gonna focus in the game. So now it's going to be within the Shadowplay recording. So low preset, 16K video resolution 4x. I'm just gonna go through it. 17 FPS. This is going to be under 16x low preset within the NVIDIA Shadowplay recording. 17 FPS. This is going to be medium preset within the NVIDIA Shadowplay recording. 18 FPS, great FPS. So you can see exactly by pause and collect the data. You can see, because this video will be unedited, single take the way it is for the best possible experience sharing, guys. As a professional gamer, professional PC hardware enthusiast, game developer, software developer, 3D artist, graphic designer, I have a lot of share with you, and I'm sharing a lot, guys, through real-time experience sharing and coming in real time. This is the only way possible. 9 FPS, great result, high preset, very high preset, DirectX 9, which is 7 FPS average, great. Cannot wait, as again, to test it on RTX 4090 video card, and RTX 3090 and RTX 3090 Ti video card. So look at this average. This is the false first. That's why I was testing 3 times each preset, because some presets will show the false data, as you can see. Just it went something wrong there. So 7 FPS average, great result, as again 7 FPS average for the DirectX 9 API, very high preset, and physics enable, advanced physics enable. Now it's going to be DirectX 11 low preset 4x, 21 FPS. So as you can see, 22 FPS without the NVIDIA shell pre-recording, while 21 FPS within the NVIDIA shell pre-recording. So only 1 FPS, it doesn't matter. But you compensate it throughout the free overclock through the software. I deliver 10% in terms of the performance boost, while 3% was used for the NVIDIA shadow play taxing. Keep that in mind. Anyways, low preset 16x, still 21 FPS average. Great results. Great results. Medium preset 20 FPS average. Exactly 20 FPS average. Okay. But DirectX 11 API, which is already using the Tessellation enabled by default under the preset. So this is the high preset DirectX 11 API with NVIDIA Shadow Play recording, 12 FPS average. Great result. Okay. Very high preset DirectX 11 with NVIDIA Shadow Play recording, 8 FPS average. Great result, by the way. Great result. Okay. Very high. Including the Tessellation enabled, but without advanced physics. But as again, it doesn't matter for tuning GPU architecture. Enabled advanced physics, very high preset, Tessellation on, with NVIDIA Shadow Play recording, 7 FPS average, almost 8 FPS average on average, exactly 8 FPS to be exact. And now the last benchmark, which is very high preset, DirectX 11 API while using NVIDIA Shadow Play recording, enabled Tessellation, enabled advanced physics, and enabled depth of field, but you saw it didn't render in real time, and while it was recording with NVIDIA Shadow Play, but I showed you without NVIDIA Shadow Play recording. So you saw all the figures that you need to see, guys. Just because this is the world's first 16K video resolution in Metro 2033 PC game, I decided to go ahead and give you a gift, guys, as being a pioneer, the first YouTuber. Decided to go ahead and give it to you. I cannot give you the Metro 2033, I don't have an additional copy for you, but I purchased the Fallout 76 full game, guys, prepaid license, legal, was pre-purchased for me as a gift for you from UHD King, from UHD King YouTube channel. It's going to be for a game, GOG game client. It's like a Steam, like a Microsoft game client. This is the code you got. This is for the first activator. You gotta use that code under the new registration of the game, GOG game client, or existing registration. If you have more games, you can activate it, no problem. And this is for the first activator. Please let us know who you are in the comments below. Just do not type your name, just tell me I activated the game, thank you so much, and positive words. Thank you so much, guys. As again, if you didn't win this time, go ahead and watch my videos as the first watcher, and you're gonna be a winner next time. Don't forget to support me, guys. Visit my sponsors, my ads, and I'm gonna collect those pennies and do more giveaways, software, hardware as well, in the future over the UHDking.com. And subscribe, smash that subscribe button. All right, so we saw that, we saw the test. Let me go ahead and real quick show you the why 16K video resolution is the maximum video resolution on the DirectX, even DirectX 12 API or any commercial or open source APIs in 2022 when it's rendering 3D in real time. And this is some information about my GPU. Go ahead and smash that pause button for those who's curious. But what you're gonna look at, level second cache, 6 megabytes, multiprocessor cores, which is streaming multiprocessor cores, SM units. This is very important. Those blocks have the CUDA cores in them, and they're using the level 1 cache on the GPU per each stream multiprocessor core, which has a lot of CUDA cores in them. They're using the level 1 cache for per each block, and then level second cache used by all those stream multiprocessor cores with all the CUDA cores as a shared. So L2 cache shared per all the streaming multiprocessors and all the CUDA cores, while the level 1 cache shared only through the streaming processor block, single block inside all of those CUDA cores inside of that block. Hopefully, guys, this makes sense. Some data and why. So OpenGL, pretty much, guys, no problem. As you can see, 16K video resolution is the maximum 3D rendering texture resolution, and 32K resolution can be rendered, but as again, not as a 3D surface, 3D world. And same thing will be applied to anything. When we're going to talk Vulkan as well, the same thing will be applied. 16K video resolution is the maximum 3D image, and the IDA 64 is pulling the maximum value out of that API. So this data is correct. Please keep that in mind, guys. Okay, and video modes, all kind of different video modes. Let me show you. I show you the GPU. Let me show you the on the DirectX is going to be the same deal, guys, but let me see. this Samsung monitor is modified, of course. I modified through the NVIDIA driver, so it's not recognizing the monitor correctly. It's recognizing as 16K video resolution. And let me demonstrate it for you. But this is the information about, let me see, video modes, GPU, Direct3D. Direct3D is supposed to show here some information, but it's going to be the same scenario for OpenGL 16K, for Vulkan 16K, for DirectX 12 API, the same deal right here. DirectX 12 API right here is going to say 16K maximum, as you can see. Okay, so this is under DirectX API 12. All right, so I showed you that, guys. Let me go ahead and switch now, and I'm going to run. After benchmark, you want to make sure that under the config user CFG is set to open to full screen, which is the windowed mode, full screen off, because sometimes it's resetting to on automatically, and it's going to flicker the shaders, and I don't want to show you it's going to be ugly gameplay with flickering shaders. So I'm going to turn it to the windowed mode. So right now it's on. Okay, windowed mode is on because full screen is off, as you saw. Save the file. So I'm going to go ahead and run. Let me see the game itself. Okay, so what I'm gonna do, I'm gonna open up my Steam. It's the Steam version. Here we go, play. Let me go ahead and demonstrate for you guys in-game performance. This is an extra bonus for those who's curious, but pretty much the FPS will be almost the same. For the best benchmarking, you want to use the benchmark tool, which has the static camera animation and everything is static, so the result will be constant. This is just to show you how it feels and provide some extra bonus information, because this is the world's first 16K video resolution. Completely makes sense. So as again, the desktop is set to 16K video resolution. I'm just going to start the game from the beginning. Let me quit to main menu. I'm going to quit to the main menu. As again, it's running windowed mode or full screen off. So it's windowed mode. Window full screen, as you can see, without any tools. It's raw. So under the video, as you can see, 16K video resolution. We're going to go ahead and start. We're going to go ahead and start at very low, which is lowest possible preset, which is low. DirectX 11 API, so I'm still going to use the Tessellation, so it's going to be a little bit heavier, but for tuning GPU architecture, as you saw, it's not such a big difference. Anyways, this is low preset, 16K video resolution, 132.7 megapixels rendered in real time, which is 110 gigapixels rendered in real time every second, as you can see. So let's go ahead and apply that, and of course it's going to flicker the screen. We gotta wait. For you, it's probably going to be black screen, but for me right now it's flickering the screen. I'm probably not going to do it like that. I'm going to, okay, I don't think I have any other choice. We gotta wait. It's going to flicker the screen about 15 seconds. I think it's switching under DirectX 11 API through all the resolutions, and just to looking to make sure that I'm running native 16K video resolution. And I'm running native 16K video resolution. I'm gonna, because I pulled the driver and I emulate the screen as 16K video resolution, and it's going to accept that. It's going to flicker, and then it's going to accept that. Hopefully it's not flickering for you, but right now it's running in windowed mode, and it's going to flicker a little bit. So what's going to happen, probably I'm going to go ahead and quit. Let me go ahead and quit it. I'm going to switch that windowed mode to the that full screen mode, because it switched to full screen mode when I changed back to the windowed borderless. Let me zoom in. Otherwise it's going to flicker, and hopefully it's still recording, because sometimes it's stopping my recording as well when I'm using the NVIDIA Shader Play, when it's flickering those shaders. Hopefully it's not, or when it's checking the resolution and stopping the video recording. Hopefully I'm still recording. As you can see, a lot of data provided, no matter what kind of field of view what kind of industry you're running. You're going to be receiving a lot of data, a lot of information. So it's off, and I'm going to go ahead and execute the game now through the Steam. It's supposed to run in windowed mode. Here we go, without any flickering. Sometimes Metro, especially almost every time, Metro 2033 PC game and Metro 2033 PC game, which is Redux version, is flickering above 8K video resolution in full screen mode. That's why I'm going to test in windowed mode, and this is how we're going to do it as the first coordinate and first vertices. So hopefully we're going to do it as well, just to make sure to compare the results of different GPU architecture, different video cards, different CPUs, different PC hardware and such. So as again, you know the deal, everything will be the same, low preset 16K video resolution, but windowed mode doesn't matter under the Windows 10 professional operating system, because it's still using DirectX 11 API over here, even when I'm using the desktop. So I'm going to start the game from the first level, and this moment can be used as a benchmark as well when it's coming on the stairs. I use it a lot, so we can compare it with the previous test that I did over the UHDking.com and the future test that I'm going to do. But look at this, everything is so detailed, even the low preset, every single pixel right there. There is so much details in those pipes that you're not going to see under low preset in 4K resolution. Even under 4K resolution, low preset, everything will be so blurred out. But over here, even if they're blurring out the textures artificially under the low preset, it's still so nice and so solid and so sharp under low preset. This is just unbelievable, guys. The level of details, as you can see, I probably should fix the field of view. You can do it, but I didn't fix it. It doesn't matter, it's just a benchmark. We're not gonna play it, but check it out. The level of details, every single scratch, everything is right here. Every single detail, even on that cop texture, which most likely going to be at least 512 by 512 pixels as minimum, maybe even 1024 pixels by 1024 pixels just on that cop. You're not gonna see the level of details if you're gonna play 1080p for sure at low, and even I would say 4K at low. Most likely a lot of details will be blurred out, but over here every single detail is right here. And yeah, this is just unbelievable, guys. So this is the FPS, as you can see at the stop. So what I'm gonna do, I'm just going to go ahead and show you a little bit of the level, as again, just because it's the world's first 16K video resolution gameplay in Metro 2033 PC game, so why not? Let me open up. I'm playing without any audio, so the audio sound's not going to distort the quality of my voice, because it's already not a great quality, because it's removing some noise out of my voice through the artificial intelligence on the CPU. But in terms of the FPS, it's not even going to be 1 FPS down. Again, it's not using the GPU, it's not using the EVGA RTX voice, which is a great tool, by the way. But check it out, guys. This is how beautiful it is. Look at this. You can see the scratches even without the zoom in everywhere. Every level of details is absolutely amazing. So what I'm gonna do now, I'm going to pretty much change the preset, and we're gonna switch to a windowed mode again. But let me switch to a low, and now we're gonna use the normal, which is the medium. Okay, hopefully, guys, at some point it's going to stop recording, because in this game it terminates my NVIDIA shell per recording. I'm not sure what point is going to be, but hopefully I'm going to demonstrate as much as possible. But believe me or not, the gameplay experience will be as same as it was throughout the benchmark, maybe plus minus 3 FPS, but pretty much 2-3 FPS, but pretty much the same. Okay, right now it's flickering. Most likely you see the black screen. For me, it's flickering green. I gotta wait. As again, I think it's switching between the resolution. You don't see the flickering, as I saw previously on a video recording. It doesn't show you the flickering, but it's flickering on my side. But doesn't flicker is again under the window mode. It only does it in a lot of games under full screen resolution when we are talking 16K video resolution, which is maximum renderable resolution for all kind of